Hello guys, today I'm going to start the implementation of my project proposal titled Proposed Design of Automatic Three Pumps Alternate Operation Controller. This is my panel and I'm going to install the internal layout. So now I completed the installation of pin rail and the cable trunking slot for the control. Next I will going to install all the components, the other contactors and circuit breaker and the relay. After that I will going to put hole to install the pilot lights for our controller. Now I already make all the markings for my pilot lights. This is the marking. I already started making a hole. I'm using the same drill and using the hole set. Guys, this is the final indicator light layout for my control panel. So the red one is for the in-camera power. This 3 is for the pump number 1, for the pump number 2, pump number 3, and this blue one is for the low water level indicator. So this is the internal layout of the control panel, the internal components, the 5 relays, and the control fuse. The 3 contactors for the motors, pumps, the main circuit breaker for each branches for pump number 1, pump number 2, and pump number 3. Here is the
terminal blocks for out power out for the motor 1, motor number 2, motor number 3, and this is for the other terminal block for the float switch and limit switches. So I designed it a little bit spacious for the future design, additional upgrade, and still have plenty of space for additional components. In this part, I'm going to test the prototype control panel. Here I have two switches which simulate the pressure switch, the the PS, and the FS or the float switch. Now here you can see the timer is on, meaning the panel is energized. All pump is in the stop mode. When our system water pressure drops, it will command the pump 1 to run. And if it is reach the predetermined set point, it will stop the pump number 1. After there's a demand of water, again the pressure will drops. This is the pressure switch. The pump number 2 is energized. The same thing, if the system pressure is full, it will stop the pump number 2. And the pump number 3 is ready for energize. See, that's the sequence of this controller. It's designed to control the 3 water pumps alternately. Pump number 1, number 2, number 3. This is the purpose of the pressure switch. And this float switch is installed to protect all the water pumps, because if the water pump running without water, it will cause damage to our pumps. So you can see here, low water alarm, meaning the tank which is serving the water pump, supplying the water pump, is full. When the water level drops while the pump is running, it will stop the entire cycle because we have a low water alarm. Even the pressure switch commands on, it will not start the pumps. It needs to reach the minimum level of the water in the tank. Let's say it reached the lowest or minimum level. Low water, but the pressure switch commands on, will trigger the number 3. Low water, stop everything. Pump number 1 is running. Number 2, number 3. Pressure switch, nothing. So let's test the trip of the overload relay. Let's say the pump number 1 trips. There's a fault in pump number 1, it will directly command the pump number 2. And let's say the pump number 2 also trip or encountered trouble or failure. It will command the pump number 3 automatically. So meaning we have continuous supply of water. And then let's say it will trip everything. So in this stage, let's say all the water pumps failed. So we need to check every now and then our control panel or pump room so that we can monitor everything. Let's reset. Pump number 1 is running. So everything goes back to normal. So that's the operation of this controller.